I'm going to cover Chapter 3, Control Structures, and the one I'm going to be talking about are selection control structures. And a selection control structure is basically the ability of a program to choose a path of execution or run parts of the program depending upon the result of some decision. Okay. All right. So here's the main points, or an overview of the main points. We're going to look at algorithms. So algorithms basically like a process or a sequence of steps to solve a problem. Conditional expression. Okay, now a computer program needs to have the capability of executing different code depending upon a certain condition. Okay, so a condition is basically a comparison. All right, a comparison. Let's say an example, a comparison and a logical operation. Let's say I have a program that wants to tell someone whether or not, or give them, allow them to join, let's say, AARP. And they have to be at least 65 to do that. I don't know what the age is for that. And so the condition would be maybe the user enters in their age, and if it's over 65, maybe your program will go out and say, okay, you can join. And if they, in the second case, of course, if they're not over 65, then you would have maybe a message that says you can't join. Okay, that would be like a really basic example of a condition. The second one is you could have a logical operation, meaning that you might have two conditions. So it might be you got to be over 65 and you have to be a citizen of the USA to be able to get to join AARP. I don't know what the conditions are. Maybe it is you have to be a citizen or not. I don't know. So you would say over 65 and citizen of the USA. Okay, so that'd be an example of using a logical operation. And there are three logical operators, or three logical operations. There's an and, there's an or, and there's a not, which means just invert the result. Essentially invert, just be the opposite of what you want. And the conditional expression, the only two possibilities of what it would evaluate out to be would be true or false. Okay. All right. The next thing is, so that's an example. We'll take a look at that more. The next thing is selection structures. Selection structures really are just, we have three of them in C++. There's an if statement. So basically means if some condition is true, execute code, or skip that code if it's false. The other one is an if else, which basically says if it's true, execute the first block of code, else if it's not true, execute the second block of code. Okay, and the third one is so-called switch statement. This one allows you to select one item from a list of items or a list of possible code blocks to execute. Okay, so it could be on 5, 10, 15, 20, 100. Something like a vending machine. We'll actually take a look at that as some of our code to see how that works with a so-called switch statement. So we have if else, and switch. Okay, the first thing is an algorithm, just defining what it is. Sequence of steps. Okay. So basically for solving a problem. And a couple of things. You want to have a good algorithm for your solution, right? Now, so what do we have? In this class, you have to actually, your end result is to write a program to solve some problem. So you define, basically, algorithm is somewhat independent of like language. It could even be independent of any language. Maybe it's your algorithm is how to bake a cake, right? And you would go through the steps of how you do that. So you'd write up the process for that solution. And you could write a program that basically, goes through the steps and says, do this, there's this. And maybe you have an automated system that, automatically turns the mixer on, automatically adds the ingredients, and maybe automatically turns the oven off and turns it off, turns it on, turns it off at the end. So you could write an algorithm for that, right? And in terms of like, what you're going to find is there's many different ways to solve any kind of problems. You know, there's different solutions you could come up with, but you want to make one that's efficient. Okay, quality and maintainability. So we'll talk more about that. But the basic idea is that, you know, when you're going to write a program, you could put it in English-like statements in terms of like what are the steps that you want to follow, and you do that typically before you actually go and write the code. Now, some of our problems don't, you know, a lot of the problems in this class it's more of an introductory class, so our solutions for problems usually pretty short. Some get to be a little bit more involved, but since it's an introductory class, usually it's like introduce a concept and you work on a few problems that are not typically that complicated. But still, it may benefit you to like write down, okay, here's a few sentences that says this is what I'm going to do. Here are my steps. Okay. Okay. There's another concept here, so-called top-down design. And top-down design basically deals with like a big picture description. So you have like your problem statement, and the way to think about this is kind of like maybe like a pyramid. And you know, at the top you just say, okay, what's my problem? What do I want to do? And then you work your way down the pyramid and you start to think about in terms of like what are my steps? You know, what do I need to do? Like my basic example I talked about, like for, you know, whether or not you can join AARP, would be the first one could be, okay, write a program that your first thing is your statement says write a program that, you know, prints a message that displays a message. If certain conditions are met, you can join the AARP, or if not, that you cannot join. So what are the things you would need to do? Well, you need to, if you're writing a program, you would need to have, you know, you need to do something with input, right? You need to have input, do some processing, and output. So in your pyramid structure, your first line, probably below your problem statement, would be, okay, input, processing, output. Okay. So that gives you kind of the next level down. And the next thing to think about, okay, how do I get input? Well, I have to have some kind of variable, you know, for my input. I need to have a message to tell the user, oh, okay, you need to enter something. And also essentially what they need to enter, right? So the input, the steps that I need to do the input, I can have maybe a few sentences for that. And then the data processing part, it might be, you know, I got to do some kind of comparison. Well, what do I want to do? I want to do a comparison between, you know, age, whatever is entered, and this age 65, let's say. And I want to do another comparison with another variable, which essentially is, you know, whether or not you're a citizen USA or something like that. Okay. So that might be, and then it's like, oh, okay, maybe display a message for one case or another, but I want to make that comparison. All right. Then the final one would be the output. Well, you want to display maybe that your output, like, and it's also part of the condition or your data processing, would be that display a message if you can join and display another message if you can't join. So that would be like a really basic example of, you know, having some English-like statements for this idea of a top-down design, right? So, so that would be kind of like just how I explained it would be what's considered pseudocode, right? So it's not really like syntax-wise, it doesn't exactly match any language at that point, but it gives you an idea of like, okay, what are my main steps? And at this point, you know, for a program like that, that's really not that complicated, you could probably translate it directly over to code at that point, right? Because you have enough detail where you can translate basically, you know, each statement into a, you know, a few lines, each English-like statement into, or English-like sentence into maybe one line of code or 2 or 3 lines of code. So it's not too bad. The other one is flowchart. Some people use these flowcharts still to design programs, and I'm just going to introduce it just to give you an idea of it, although we're not going to I'm not going to require that you know, flowchart any of your programs. Later on in your career, you may be required to do that, but not in this class. Okay. Okay, so, oh, one more thing before we actually press on to the language. So you have solutions to problems, right? And you've come up with algorithms. And we're more talking about, we're going to talk about the main concepts here. And, our solutions are relatively simple, but these are definitely things to keep in mind as you move forward. And it's actually could apply to other types of engineering solutions besides programming. But here's some things to think about, right? Your solution or whatever your solution or has to meet these requirements, right? It has to be correct. So it has to be, is it a correct solution, right, to that problem? Yes. Reliability, right? If you have a solution, and it's interesting to think about this in terms of a programming language, it has to be reliable, right? It's always going to give you the correct result, right? With a high level of confidence, right? That you're going to get a correct result from the code. Our programs are pretty basic, so this is not like once it works and we can demonstrate it works. We could have a pretty good idea that our reliability is also good if it works, okay? Next is readability. So your code should be written in such a way, and we'll talk more about this, but your code should be written in such a way that later on you could go back and look at it and figure out what it does fairly easily. Or, if you're part of a team and you're writing code, that you want to be able to, if someone else comes and looks at it, right, they're like, oh, what does this code do? Well, just how you structure your code and what you put in comments, you can actually make your code fairly easy to follow, right? And, on the other side of that, of course, is that if you don't do it well, it could be really difficult to follow, okay? Maintainability. So in this case is, hey, if I need to modify the code, make changes to it, is it easy to do that? So is it structured in such a way that makes it so that it's easy to make changes later on if you need to? And one of the things we're going to talk about is modularity, where you're breaking up your code into different blocks. And we do with this thing called functions. And that's really helpful for maintainability, that if there is a change that needs to be made, you want to try to kind of restrict that or the impact of that change to a smaller piece, right? So that you don't impact everything. So the idea could be like a car engine. Car engine has hundreds, or probably hundreds of parts at least, thousands of parts. That if something goes bad, you wouldn't want to have to change the whole engine, right? You have pieces that you could actually go in there and replace, okay? If needed, right? Execution speed. So computer processing power is limited, of course. As time goes on, it keeps increasing and increasing, but execution speed is an important consideration. And the last one is memory, right? And same thing with memory is like, well, for our code, you push the button, you say execute. It's so fast, of course, in the modern computers that you won't even notice the difference. But these are things, going further on, that if you're developing software, you'd have to think about, okay, how fast does it run, right? And also memory, how much computer memory does your program use, all right? But these two, although they're listed here, you're really not going to be able to tell the difference. So it's like if you have, if you're comparing two solutions, one uses less memory, that might be a decision for you to make to choose that one. Or it could be that, one of a variety of solutions has better execution speed. You may choose that, right? So these are considerations. Oh, and user interface. So how does the user interface that? For us, we're just doing console programs because we're more concerned with what's happening in the background, is that the user interface would be something that should be, clear, intuitive, easy for someone to follow, and something that they're familiar with. Try not to make it too much different than people are typically see. If it's a Windows program, it usually has a certain structure. Okay. Okay, structured programming. Okay, C++ is in other languages, Java, follow the so-called structured programming model. And the basic idea is that, when you're writing code, this is how the flow of the program execution can follow one of these three approaches. And first one is that program execution happens in sequence. Okay, so it's like one step after another. So like if you write one line of code, it executes the next line of code after that one, that executes after that, and then the following one. Okay. Selection, the other one is a selection structure. So it could follow sequence, selection, or repetition. Selection structure basically means, one line of code executes, then you maybe reach a one of our control structures, selection control structures, and a decision is made, and then either, like I said, code is skipped or code is executed, or, if it's an if-else structure, this code is executed or the next block code is executed, all right? The next one is repetition structure, which we'll take a look at in chapter 4. And this one is just basically means depending upon some condition or something happens, you repeat a block of code. So you repeat it over and over again. So if you think about it, like in terms of like capability, you want your program to make decisions based on something, right? Something that happened. And also you want your code to be able to repeat, right? Repeat the same code over and over again. It might be that repetition of code is prompting the user to enter in something. Maybe you want to check to see if a person entered a Q at the keyboard, right? So you'd say, okay, give them a message, prompt them, say, okay, enter a letter. User enters a letter. If it's a Q, maybe you put a message, oh, you entered a Q. If not, repeat that code and go back and say, enter another letter, and keep asking them to enter a letter until they enter a Q. Okay, that's like a really simple example of a repetition structure. Okay, but for now, in this chapter, we're just going to deal with selection structures. Repetition structures will be dealt with in the next chapter. Okay. So here's a really brief overview of if you're using flow charts. Okay. What does this rectangle represent? Basically, it means some block of code or some part of your code program that's going to execute. Okay. So if you see something like this, it means, okay, whatever's up here, execute, then after that, execute this, then after that, execute the next rectangle, whatever's in there, and keep going step by step by step, okay? And flowchart is another, like, design tool, so you can use it to, you describe what your program's going to do first, you use flowcharts to describe that, and then you can go in and write code from that description. All right, the next one's selection structure. And what does it mean? Code execution's coming down here, coming down, following along. Then you get to a statement and it says, oh, what do I do? Like I said, the one I had before was, let's say it's a real simple one. Like I said, if you're under 65, true, display a message. Sorry, you can't join AARP. And then the next one is it false? You're under 65, false, meaning you are over 65. Then this one would be, yes, you can join, right? This would be a message. So you have one of two possibilities. The next one is the repetition one. And like I said, with maybe you're prompting the user enter a letter. Right here it says, you come down, you prompt the user, come down here, check it. Is it a Q? True. Or is it not a Q? Let's do the inverse, right? Is it not a Q? True. Prompt the user, here's the code in here to say, prompt the user to enter another Q. And you come up here, come up through this way, check it again. Is it a Q? Is it not a Q? Right? True. Do it again. Then if the user enters a Q, is it not a Q? False, because it is a Q. And then you follow this path here. And you go on to whatever the next code is down here. Okay. But these are flowcharts, and they're only actually two symbols that we show here, right? It's like the rectangle and the diamond representing a decision. Okay. So here's conditional expression, whatever. Just have that. That's what the question mark represents, conditional expression. Okay. Okay, so we want to build a conditional expression what we're going to do is we use so-called relational operators and logical operators. Okay, so I'll show you those, and so conceptually we'll take a look at it first, and then we'll write some code using it. Okay. Okay, so here's the relational operators in C++. Okay, so we have equality. If you're comparing two things, age and let's say whatever it is, maybe you're, like I said, maybe the only thing I think of right now is age. Age equals 65, then you would come up and say true. You know, maybe you have a message, you are 65, right? This is just the inverse. This one says if it's less than, execute some code. If it's greater than, execute less than or equal to, or greater than or equal to. What you're going to recognize is that these are comparison. They're basically making a comparison, right, between two quantities. If you're using this, and you can use these in different structures. You can use them in if structure, else structure. You can use them in a, can't use them in a switch statement, but you can use it in an if statement and an if-else statement, okay? When you're using these, the only result of this operation is either going to be true or false, okay? All right, so let's continue on. Logical operators. So if you want to make so-called a compound conditional expression, meaning have more than one comparison, you could have multiple ones. You could have 3, 4, 5. There's really no practical limit. You also use logical operators. Okay, so how are you going to combine those relations, right? Like I had an example when I said that, you know, are you over 65 and a USA citizen? You would use this. This is, the meaning is over here. This is the actual symbol, okay? Okay, so when we're talking about logical operators, logical operations, and we'll take a look at this, but this is like just a truth table for those basic logical operations. And let's say I have two variables, two things. One's called, or not two variables, I shouldn't say. It's not two variables. A represents a relation, some comparison, and B represents a relation or some comparison, right? In our C++ language. And the basic idea is, let's say the first one becomes false, the second one is false. Sorry, first one is false, the second one evaluates a false, and these are all the possibilities, right? Because it's either true or false for each of those relations. The first relation and the second relation are both false. If this is an and, saying, oh, A and B are false, then, if A or B is false, this is going to give you a false, right? Because in order for this to be true, I need A to be true and B to be true. And that's the last one here, okay? Now, this is an OR operator. What this one says is that if either A or B is true, the result is true, okay? So if I do an OR operation of A is false, B is false, then they're both false, so this is false. Anytime either one of these is true, or they're both true, when you use this operator, they're both going to be, it's going to be true. Okay? Now, this is just the inverse of A, and this is the inverse of B. Okay, so like I said, you recognize that A is a relation, and B is another relation. Okay, and this just basically says, you know, if you have those two relations, and what evaluates out, is it true or false? If either one of those evaluates out to false, then of course in this case this is the and result of the anding of these two, it's going to become false. Okay. All right. So the operands could relations. You could put a, you know, you could say 0 or 1 if you wanted to, and make it true or false right off the bat. I don't know why you'd want to do that, but you could. Okay. But recognize that in our using them here in this class, A is a relation, you know, like some kind of comparison. It could be like age is 65 or whatever, like less than 65, and B is another relation, okay? Okay, the next thing is the operator precedence. So when we start to go through and evaluate conditional expressions, we need to pay attention to the operator precedence, okay? So this is so basically anything higher, so it starts off, this is first, this would be evaluated second, third, fourth, and fifth. Okay, so these are the relational operators here and here, and here are our logical operators. Okay. Okay, so here's some practice. You can pause it and see if you can figure out. Now, these will evaluate out to either true or false. Okay, but we can take a look at it. So you can, if you want to pause the video here and then see if you can figure it out, and then I'll go through those. Okay. All right. So first thing is, if we look at this first one, and things inside the parens will be evaluated first. So if we go back just to show you quickly. So parens are first. Okay. So parens first, then the relational operators, then the logical operators. Okay. All right. So is -6 less than 0? This would evaluate out to true. And then we evaluate this one because parens have the highest precedence. Is 12 greater than or equal to 10? True. So this would be true. This part's true. And then this gets evaluated. Okay. And if you look back, just again, that's at 4. So really just have this gets evaluated first, then the relational operators, and then the logical AND operator. Okay. So this one is true and true. This becomes true. Okay, let's look at the next one. Now I took the parens out. There's no parens in either of the next two, but we can look at this. So this one is an OR. Okay. Well, relational operators get evaluated before logical operators. So this is true. And well, one of them's true, then that's enough for the whole thing to be true. And this one is false. Okay. But since one of them's true, the first one values out the true, so it'd be true, and this is false, be true or false, and this one evaluates out to true also. Okay. Now let's look at the next one. Now, relational operators are first, so this is going to be first. And also the other thing too is that it gets evaluated over left to right, so it starts at the left and goes to the right. Right. So this one is true, so it'd be true for this one. This one is false. And this one is true. Okay, so now I have true, false, true. Okay. Now the question is which gets evaluated next, the or the and? If we go back up, we see and gets evaluated before or. So this one is, so this becomes this is what I said. This one is false, and this one is true. So false and true becomes false. So this evaluates out to false. Then you evaluate this operator, so it becomes true or false. So the whole thing evaluates out to true also. Okay. So these are all evaluate out to true. Okay. And so you can also look at other examples. And there's some other examples like on, I see on 114, practice 3-1 has some examples on there. Precedence and associativity. There's also a more detailed list of precedence, table 3.3 on page 114. So when we're talking about operator precedence, page 114 also has a table that's that shows you the operator precedence and logical operators. So let me go back up to this. You also find this on table 3.1 on page oh, and there's an expression to turn on that page also you can go through and evaluate, but this is on page 111. Okay. Okay. Okay, so that's good now for this first part. Covered the remainder of the chapter in a second part of video.